we had this World War II that came in the way, and then he came back at Columbia and was working on this idea, and then they were able to show that actually the energy levels are not the way the Dirac equation comes, because there is a little jitter on the position of the electron, because we have this phenomenon called zero-point energy in the electric field. So we think, okay, the vacuum, that's empty. No, it's not empty. It is filled with all the modes which could be there, but we have only half a photon in each one. And those add all up and they jiggle the electron, and when the electron goes in, it gets close to the nucleus and there's a big attraction. When it goes far away, it attracts less, and it's more big when it's in than it is more or less when it's far away. So there's a net effect from that. So depending on what the orbit was, whether it's a circle or a line orbit, you've got a splitting. And okay, that's pretty interesting. That introduced then what is this effect about? And this explanation I just gave you was given by Welton. And then a really smart young guy called Richard Feynman came by and he says, oh, I think I can figure out how to calculate that. And he made these graphs that he's famous for, and we introduced a whole nother subject, which is quantum electrodynamics. You know, that's now the basis of everything. Special relativity is in that. And then field theorists that are trying to understand nuclear matter, they start with that and they say, okay, well, I'm going to describe this quark by some fields, and on it goes. It's, to me, it's just absolutely fascinating to try to understand how this goes.
The question that I have is that when light travels, goes from a rarer medium to a denser medium, the velocity or speed changes.
Oh, yeah.
So what does the change takes place? Is it with the lambda, or is it with the nu, or is it with both?
This sounds like a trick question. It's because what I was doing in the consulting role to a startup company is doing that experiment in the other way. It happens just the same way, but it enables one to diagnose the index refraction of the top material that's on the top, which could be a bioactive surface. And I think the theory that we have for describing these will show index refraction or dielectric constant as the parameter for it. And so there's a tight, fixed relationship. For sure, we know that if you send a wave into this glass thing and then the wave is coming back out, there's no place for the glass to store up 11 waves for 10 that an extra wave that went in. So I'm guessing that the frequency is conserved, and that's what we think the energy goes with. And then we have the index of refraction, and that messes with the velocity, and that messes with the wavelength. That would be my take. But if you buy beer and we talk about it later, maybe I could be persuaded to another opinion. I think that's the right thing.
Okay, any more questions? Well, we have some more time during reception. You can certainly ask him more questions. Let us thank him again one more time. Now I will request our Vice President for Institutional Research and Planning and Sponsored Programs, Dr. Teresa Oro, to bring us some acknowledgements. There is a lot of effort goes in doing this, so I will request her. She's coming to the stage, and then after that, of course, I invite all of you to have a reception. We have a lot of food for everyone.
My name is Bill. The question, we're just in a basic physical science class and in Oakwood, and my question to you is, my teacher says that we've not been able to make anything that can go faster than the speed of light.
That's true as far as we know, but it's also a little bit about measurement, because we don't have tools.
can give him another round of applause. We thank him for accepting our invitation to visit Alabama A&M University, his motivating interactions with students and faculty of the physics department, as well as other faculty and students from across the campus. Dr. Hall, we would like you to know that your visit here has been a special delight for our research community. And we hope that out of this visit will come future collaborations that are beneficial for our students and our faculty, as well as for our entire research community here in the Huntsville and Madison County area. Indeed, we recognize that this could not have been possible without the foresight and hard work of some very committed individuals. It is therefore my pleasure to thank the sponsors of this meeting for their generous contributions. In addition to Alabama A&M, the physics department, and certainly I do want to recognize the great work of all of the faculty and staff in putting together this program. I also want to recognize the efforts of the following individuals and institutions who have contributed to the success of this program. So as I call your name, if you would please stand. From the School of Agriculture and Environmental Sciences, we want to thank Dr. Robert Taylor, who serves as Dean. Thank you, Dr. Taylor. From Oak Ridge Associated Universities, Dr. John Nemeth. He's not here, but we certainly want to thank Oak Ridge Associated Universities and Dr. Nemeth for their support. Raytheon, thank you. Raytheon Missile Systems is Mr. Joseph Walsley here. Thank you so much. And we appreciate the collaboration. Dr. John Horek from NASA. Marshall Space Flight Center. Okay. Is there someone representing? Thank you. Thank you so much, sir. And we certainly appreciate this long-standing and fine relationship. From CFDR, we want to thank Dr. Sinho. Thank you. And from U.S. Army AMRDEC, Dr. Paul Ruffin, who has been with us since early this morning in another program. Is he still here? Okay. So well, I can attest to the fact that he has been here since about 8 o'clock with the engineering program. And also SS Optical, Dr. Sakirza. Thank you so much. I certainly want to recognize our other deans who are in the audience, Dr. Trent Montgomery. Thank you for your support. And for all of the fine students and faculty of this great institution, thank you for your support. Did I miss anyone back there? Okay. As Dr. Agarwal comes, you know there are some of us who are so very modest. But this gentleman does an excellent job each year with not only this program, but with other programs. And we certainly want to thank him. We also want to thank WLRA to National Public Radio and the Huntsville Times for their publicity. Our own Public Relations Department, the campus telecommunications, thank you for videotaping this lecture. And are you making it available?
On the radio.
Okay, it's on the radio. Okay, Dr. Hall, do you have a copyright on the distribution?
What if they use it in prosper or something that they say in StarTech? Live well and prosper? I don't remember.
Okay, okay. So maybe that is something that you and Dr. Aguilar can look at, because there may be individuals who are interested in obtaining a copy of this. And certainly to our person who says that he has retired from this great institution, who has been a mentor for all of us, Dr. Lau, we want you to stay. We thank you for your continuous support of all that you do here at Alabama A&M University. Thank you.
Now I will request Dr. Lau, he has some announcement for us for next year.
Tried very hard with Dr. Hall to convince him to come down here in spite of many no's, and successful in getting him here. And I'm very glad to announce that next year I'm working on Dr. Smoot on the Nobel Prize in 2006 for the discovery of the black body form and anisotropy of the cosmic microwave background radiation. He got the Nobel Prize in 2006. And I hope that I'm pretty convinced 90% that he's coming, but still I don't have in writing. But I'll try my persistence I did with Dr. Hall, and I'm hopeful you'll hear him next year. So I think I personally want to thank Dr. Hall and Mrs. Hall, who's here, for their visit to this campus, and we are very pleased that you are here, and so glad to do that. And I want to request all of you that please do not leave. We have a reception in a building which is just, if you go out on the right side, there are students here who will guide you. And you don't have to take your cars from here. You can leave the cars in this parking lot and move just outside the door. And it's a very 3 minutes walk or 4 minutes walk, depending upon your speed. Thank you so much, and we'll see you at the reception.
For that review. Yeah, I got it. That gives us that. And I write. And so how does that? I always know that.
Excuse me, if I can have your attention, Dr. Maureen Stewart. I am so sorry, I did not see you there. Dr. Stewart, if you raise your hand, please. She served as our interim provost and vice president for academic affairs. Thank you so much.